Today we're going to discuss derivative of exponential and log functions, and we will also look at logarithmic differentiation. So let's talk about the definition of natural exponential function. Definition of e to the power x. The function f of x is equal to natural log of x has an inverse because it passes through the horizontal line test. The inverse of natural log of x is e to the power x. Because these are inverses, it holds that natural log of e to the power x is equal to x, or e to the power natural log of x is equal to x. Now we're going to review some exponent rules that we learned in algebra. E to the power a times e to the power b, we can add the exponents. If we have a quotient, we can subtract the exponents. If we are multiplying e to the power 4 times e to the second power, then we can add the exponents. It would be e to the sixth power, e to the third power, e to the power negative 4, which can be written as 1 over e to the power 4, and e to the power 0 is equal to 1. Special limit involving e, limit x approaches infinity 1 plus 1 over x to the power x, or this limit and this limit. These are the definitions of number e. We're going to see a proof of the derivative of e to the power x and natural log of x in this video later. So logarithmic properties. Natural log of 1 is equal to 0. Natural log of a times b, we can write it as natural log of a plus natural log of b. Natural log of a, we can pull out the exponent in the front. If we have natural log of quotient, we can write as natural log of a minus natural log of b. Properties of natural exponential function. The domain of exponential function, think about the exponential function graph, looks like this. The domain is all real numbers. It does take all x values, and the range is 0 to infinity. 0 is not included. E to the power x is continuous and differentiable in its domain. It's continuous and differentiable in its domain. E to the power x is going to be concave up. We will talk about concavity soon. Concave up looks like this, concave down looks like this. So e to the power x is concave up on the entire domain. Limit x approaches negative infinity e to the power x, that is going to be e to the power negative infinity, which is 1 over e to the power infinity, that's going to go to 0. And limit x approaches positive infinity e to the power x is equal to infinity. And you can also see from here, as x is getting really large, y is getting really large. So when we go to positive infinity, the y values are also getting very large. When x is getting very small, the y values are getting closer and closer to 0. Derivative of natural exponential function. Derivative of e to the power x is e to the power x, and derivative of e to the power u, where u is a function of x, in that case it would be e to the power u times derivative of the inner function times du dx, which is the chain rule. So let's look at some examples. Derivative of e to the power 2x minus 1 would be e to the power 2x minus 1 multiplied with the derivative of inner function, which is 2x minus 1. So 2e to the power 2x minus 1. Derivative of e to the power negative 3 over x times derivative of negative 3 over x, which is going to be negative 3x to the power negative 1. The derivative would be 3x to the power negative 2 times 3. I'm going to bring the x in the denominator just to make it positive. That's going to be the derivative in this case. Again, now we have a product rule, and we'll also have to use a chain rule. So derivative is going to equal x squared times derivative of e to the power 4x multiplied by 4 because of chain rule, e to the power 4x times 2x derivative of x squared. So 4x squared e to the power 4x plus 2x e to the power 4x. That's going to be the derivative in this case. Derivative of natural log of x, or log to any base b, and derivative of bases other than e. Derivative of natural log of x is equal to 1 over x. An easy way to do the proof is using logarithmic differentiation. We can also use the limit definition to do the proof here. Derivative of b to the power x, if the base is something other than e, then it's going to be b to the power x natural log of b. Derivative of e to the power x is just e to the power x, and derivative of log of any function of x to any base b. We know derivative of natural log of x is 1 over x, but what if your base is something other than b? Then it's going to be 1 over x times 1 over natural log of b. Okay, I'm going to be making another video of the proof, so I'm going to get to the examples now here. Derivative of 5 to the power x. How would we find derivative of 5 to the power x? It's going to be 5 to the power x times natural log of 5. 5 to the power x times natural log of 5, because your base is something other than the e. So natural log of, we do that with the base e as well, but natural log of e is 1, so that doesn't really make any difference. Derivative of 2 raised to the power 3x, that would be 2 raised to the power 3x. Derivative of times natural log of 2 times the 3. So 3 natural log of 2 times 2 to the power 3x. Okay, next, find the derivative of each function. Y is equal to 3 to the power x. Y prime would be 3 to the power x natural log of 3. Y prime is 1 over x. Y prime is 1 over x times natural log of 5. If your base is something other than e, we multiply with natural log of that base. Y is equal to 4 to the power 3x. Y prime is going to be 4 to the power 3x times 3 times natural log of 4. F prime of x would be 5 to the power x squared times 2x times natural log of 5. Y is equal to x times natural log of x. Y prime, we have to use a quotient rule here. X times derivative of natural log of x is 1 over x plus natural log of x times 1. So y prime turns out to be 1 plus natural log of x, because we can cancel the x and x. Next, we are going to have to use the chain rule here, and we'll also have y is equal to natural log of x squared. So y prime would be 2 natural log of x times 1 over x, which is 2 over x natural log of x. Y prime would be natural log of something. Derivative of natural log of x is 1 over x times the derivative of inner function, which is 3x squared. Or we can say y prime is 3x squared over x to the third plus 1. Y is equal to log of x. What's the base over here? The base is 10. When you don't see a base, the base is 10. 1 over x natural log of 10. Okay, y is equal to natural log of x to the third. There, we have to use the chain rule here. So let's start by y prime is equal to 1 over natural log of x to the third times 3 natural log of x to the second power times 1 over x. So we'll have to be peeling over here. Start with the outermost function and then keep going until you get to the innermost function. So here we can cancel some of the factors. These can be gone. 3 over x natural log of x is what gonna be my derivative in this case. F of x is equal to 2 to the power x minus 3 to the power negative x over x. We will have to use a quotient rule here. So low d high, derivative of 2 to the power x. Derivative of 2 to the power x is 2 to the power x natural log of 2 minus 3 to the power negative x times negative 1 natural log of 3 minus 2 to the power x minus 3 to the power negative x times derivative of lower function, which is 1. And from here we can simplify it if we want to, but I'm just going to leave it at this point. Find the second derivative of 3 to the power x. So we want to find the second derivative. First derivative would be 3 to the power x natural log of 3. The second derivative would be, we already have a natural log of 3 pulled out, 3 to the power x natural log of 3. So natural log of 3 squared times 3 to the power x, that would be our second derivative in this case. All right, logarithmic differentiation. Logarithmic differentiation makes the tedious problems easier. So we can use the logarithmic differentiation to make our life easier. We would have to take log on both sides. So we'll have to take logs on both sides, and we'll be able to break our function into smaller chunks if we have product and quotient of crazy functions. We'll be using implicit differentiation in this case because we will be using the logarithmic differentiation here. So let's see, differentiate the given function. So we're given this function f of x is equal to 3x plus 5 times 4x plus 9. Not bad. I could have just went ahead and multiplied both the parentheses and then go ahead and perform the differentiation at that point. But I can also, I'm going to say this is y is equal to 3x plus 5, 4x plus 9. I'm going to go ahead and take natural log on both sides. Take natural log on both sides. So natural log of y is equal to natural log of 3x plus 5. Natural log of 3x plus 5 times 4x plus 9. Now, beautiful here property of logs we can use. Instead of doing natural log of one big thing, we can say this is going to be natural log of 3x plus 5 plus natural log of 4x plus 9. We can write 3x plus 5, 4x plus 9. We can write product of, if we have a single log with a product, we can write it as two separate logs with the plus sign in the middle. So now we're going to go ahead and do the derivative on both sides. Derivative on left hand side, be careful because y is a function of x. Derivative of natural log of y would be 1 over y prime. We are using implicit differentiation. Every time we take derivative of y, we're going to tack on a y prime because y is a function of x. Derivative of natural log of 3x plus 5 would be 1 over 3x plus 5 times derivative of inner function plus 1 over 4x plus 9 times derivative of inner function. Okay, 1 over y prime is equal to 3 over 3x plus 5 plus 4 over 4x plus 9. Now we wanted to get y prime by itself, so I'm going to multiply both sides with the y to isolate my y prime. Finally, I can say the y in the beginning, what did we call y? Y was this whole thing. So I'm going to write it as y is 3x plus 5. So y prime turns out to be 3x plus 5 times 4x plus 9 and 3 over 3x plus 5 plus 4 over 4x plus 9. Now we can distribute and simplify. I'm going to leave that part for you. Another example, use a logarithmic differentiation to find the derivative. As you can see, this problem is not so pretty. It's a crazy problem because we have the exponents, we have multiplication, we have quotient rule, product rule, and we have chain rule. So tons of things involved in here. I'm going to go ahead and use the logarithmic differentiation. That's going to make my life easier. So y is equal to x times x plus 1 to the third over 3x minus 1 to the second power. Take natural log on both sides. So I'm going to say natural log of y is equal to, so in the numerator, I have a product, natural log of x plus natural log of x plus 1 to the third minus natural log of 3x minus 1 to the second power. Another beauty about the logarithmic functions is that the exponent becomes a coefficient. So natural log of x plus 3 natural log of x plus 1 minus 2 natural log of 3x minus 1. Now go ahead and take the derivative on both sides. Take derivative on both sides. Take derivative on both sides. So 1 over y prime is equal to 1 over x plus 3 over x plus 1 minus 2 over 3x minus 1 times a 3. Don't forget the chain rule. You also have to multiply with the derivative of the inner function. So simplifies to 1 over x plus 3 over x plus 1 minus 6 over 3x minus 1. To isolate the y prime, we're going to multiply both sides with whatever we called y in the beginning. That turns out to be the y was the entire, we're going to replace y by that whole expression. So y prime turns out to be, the y is x times x plus 1 to the third over 3x minus 1 to the second power times 1 over x plus 3 over x plus 1 minus 6 over 3x minus 1. 6 over 3x minus 1. Okay, and I'm going to leave it at this point. Again, you can go ahead and simplify, distribute inside and simplify. I'll leave that part for you. Sometimes it's not easy to simplify and we would be okay to leave it at that point. Find the equation of tangent line to this function at x equals 1. Okay, so how do I find the equation of tangent line here? First of all, I need the slope of tangent line. Slope of tangent line is a derivative. Slope of tangent line is the derivative. So y prime in this case would be pi to the power of 5x minus 2. It's an exponential function times natural log of pi times a 5. So y prime when x is 1 is going to be pi raised to the power of 5 minus 2 is 3 times natural log of pi times a 5. That's the derivative when x is equal to 1. We also need a point on the line. To point on the line when x is 1, what is the y value? So we're going to replace x as 1 in here. That would be pi to the third power. Now this is my point x1, y1, and this is my slope m. So equation of tangent line is going to be, we can use the point slope form. Y minus y1 is equal to mx minus x1. y1 is pi to the third power. M is 5 natural log of pi times pi to the third. X minus x1 is 1. 5 y minus pi to the third, 5 natural log of pi to the third, x minus 5 natural log of pi to the third. Finally, we can take this pi to the third to the other side, and 5 natural log of pi to the third, x minus 5 natural log of pi to the third plus pi to the third, and that's going to be our derivative in this case, pi to the third. That's going to be the slope of the equation of the tangent line, not the slope of tangent line, not the derivative, I'm sorry, equation of tangent line. See another example. Here again, we're looking for y is equal to log to the base 5, 2z squared plus 7, equation of tangent line to this function at z equals 3. So we need slope of tangent line. Slope of tangent line is the y prime. That's also called m. That's going to be 1 over derivative of log to the base 5, that would be 2z squared plus 7 times natural log of 5 multiply with 4z. Okay, that is my derivative. That turns out to be my derivative. Y is equal to natural log of we could also write it with the natural log if you wanted to, or this is fine the way it is. It's perfect. Okay, we can always use change of base formula also and write it in terms of natural log if you wanted to. So this is my derivative. Y prime at z is equal to 3 is going to be 1 over 3 square is 9 times 2 is 18 plus 7 natural log of 5 times 4 times 3. So y prime at z is equal to 3 is 12 over 18 plus 7. That would be 25 natural log of 5. 12 over 25 natural log of 5. That is my derivative. And the point on tangent line, x1, y1, x1, we are given z is equal to 3. That's taking the place of x in this case, and the y would be log to the base 5. 3 square is 9 times 2 is 18 plus 5 log to the base, which is going to be 3 comma 2. Okay, now we are ready to write equation of tangent line. To write equation of tangent line, we would be able to y minus y1 is equal to mx minus x1. Use the point slope form. Y minus y1 is equal to m x minus x1. From here, go ahead and isolate the y if you want the slope intercept form, or you can leave it in this form. Okay, now we're going to look at some more examples where we're going to be using, these are not just the exponential functions, because the exponential function only has a variable as an exponent, and these are not polynomials, because polynomials have x's as the bases and the integers are exponents. That's not happening in this case either. Both base and the exponents are, in this case, both base and the exponents are variables. So in this case, both of them are variables. We don't have a constant base or a constant exponent. So what we're going to do here is we have y is equal to x to the power x to the second power. Okay, we can start thinking whenever you have x to the second power, we would consider this as our exponent. Okay, we would start our exponent from the far right side. Okay, we'll start considering those as the exponents. So I'm going to take natural log of y is equal to natural log of x to the second power. This is my exponent that comes in the front, x squared natural log of x. Go ahead and do the derivative. 1 over y prime, product rule here, x squared times derivative of natural log of x is 1 over x plus natural log of x times 2x. So 1 over y prime, cancel the common factors, x plus 2x natural log of x. Y prime turns out to be y times x plus 2x natural log of x. y prime is equal to x to the power x to the second power x plus 2x natural log of x. And that's the derivative in this case. We were able to use the logarithmic differentiation and break it. So here's something I want to clarify, that if you have the function is equal to y is equal to x to the second power, it would be, you might think that, not y, you might think that you can write it as x to the second power or x to the second power. This is not the correct notation. This is the correct notation. So you start your exponents from the far right side, okay? Far right side, you will start getting your exponential functions. Because a to the power b to the power c is not a to the power b to the power c. That's not what it is. It's a to the power b to the power c. That's what it is going to equal. Okay. Another example, find the derivative of y is equal to x e to the power x. Derivative of y is equal to x e to the power x. Again, we just talked about, we're going to consider this as one thing. Natural log of y is equal to natural log of x e to the power x. Natural log of y is equal to, the exponent comes in the front. Now we're going to go ahead and do the derivative. 1 over y prime ex. Derivative of natural log of x is 1 over x plus natural log of x. Derivative of e to the power x is just e to the power x. Turns out to be e to the power x over x plus natural log of x e to the power x. Lastly, isolate the y prime by multiplying both sides with a y. Y was x e raised to the power x. Give myself a little more room here. Y prime turns out to be x e to the power x over x plus natural log of e to the power x. And that is my derivative in this case. I could go ahead and distribute. I don't know if that's going to make it any simpler or not. I'm just going to leave it at this point. Let's see. Find the derivative of f of x is equal to e raised to the power x to the power x. Again, think about, that will be one thing, x to the power x. So y is equal to e to the power x to the power x. That's going to be considered one thing. Natural log of y is equal to natural log of e to the power x to the power x, which gives me natural log of y is equal to x to the power x natural log of e. Okay, natural log of e is 1, so that is going to be gone. This piece will be gone. Natural log of y would be just x to the power x. Now here, I'm going to consider a totally different problem that has nothing to do with this one. What if my y was x to the power x? Natural log of y would have been x natural log of x. I think we also did this problem earlier. 1 over y prime would be x times 1 over x plus natural log of x. Y prime would be y times 1 plus natural log of x. Y prime is x to the power x times 1 plus natural log of x. Now the derivative, when we go ahead and do the derivative on both sides, because now I'm going to take derivative on both sides, I'm going to use what I just found from the other problem that I created. So derivative of the left hand side is 1 over y prime. Derivative of x to the power x is x to the power x 1 plus natural log of x. Y prime turns out to be y x to the power x 1 plus natural log of x. Y was e raised to the power x to the power x to the power x 1 plus natural log of x. And that's it for this problem. Really quickly, we can use implicit differentiation to prove if y is e to the power x, then y prime is e to the power x. We can use implicit differentiation to prove that. So we can use logarithmic differentiation to prove this. This would be an easy proof. There's many other ways to prove it. Natural log of y would be natural log of e to the power x. Natural log of y is x natural log of e. This piece is equal to 1. Now, go ahead and do the derivative. The derivative of x is 1. Y prime turns out to be y, which was e to the power x. That's one way to prove the derivative of e to the power x is just e to the power x. Now, let's quickly also prove the derivative of, if y is natural log of x, y prime is 1 over x. Okay, let's go ahead and use the natural logarithmic differentiation again. Let's go ahead and take natural log on both sides. Natural log of y is equal to natural log of x. 1 over y prime. Derivative of natural log of x is 1 over natural log of x times derivative of natural log of x is 1 over x. Y prime turns out to be 1 over natural log of x times 1 over x times y, which is 1 over natural log of x times 1 over x times y is natural log of x. We can quickly cancel these, and that turns out to be 1 over x. So if y is natural log of x, the derivative turns out to be 1 over x. Okay, one more example. Let's go ahead and check this out. A line with the slope m passing through the origin is tangent to the graph of this. What is the value of m? Okay, a line with slope m passes through the point and is tangent to the graph of this. So we're looking about a tangent line to this. Tangent line to this function, what is going to be the slope of tangent line? Slope of tangent line at this point is going to be the derivative, which is going to be 1 over x. Slope of tangent line is going to be 1 over x. What is the value of m? We're looking for the value of slope. So what is the point here? The point y is equal to natural log of x. Y is natural log of x. And it passes through the origin. So if it passes through the origin, it means it goes through the point 0, 0. So let us say that let's say natural log of the point would be natural. Let's say it's point A. Say it's the value of m we're thinking about. So what we can say is y prime is 1 over x. We already see that. Passes through the origin and is tangent to this graph. Okay, so let's say line is touching the graph. Line is touching the graph. At point, line is touching the graph at point x equals a. If x coordinate is a, the y coordinate will be natural log of a. Okay, that's going to be the point on the line, x1, y1, right? That's going to be the point on the line. So y minus y1, we're going to write the equation of tangent line, y minus y1. y1 is natural log of a is equal to m. M is the slope at that point. When x is equal to a, the slope would be 1 over a, x minus x1, x minus a. So, and this equation has to satisfy 0, 0 because it passes through the origin. 0, 0 minus natural log of a, 1 over a, 0 minus a. Negative natural log of a is 1 over a times a. Negative natural log of a is negative 1. Natural log of a is 1. A turns out to be 0. So a turns out to be 0. If a is 0, then 1 over a is 1 over a is equal to 0. It would be negative natural log of a e raised to the power 1 is equal to a. Oh no, a is not going to be 0 here. It's not going to be 0. Natural log of, so this is going to be e raised to the power 1 is equal to a. A turns out to be e. A is e, so my slope of tangent line would be, what is the value of m? Value of m would be, the m is your slope of tangent line. That's going to be 1 over x, which is going to be 1 over e. 1 over e is the slope of the tangent line. That would be all for this problem.